But I think I'm going to do this sitting with my panel since we have enough seats rather than at the podium. But before I jump in, I just want to provide some context to this panel. Space mining is something that for many years has sounded like science fiction. But those of us in this room and everything you've heard today is about taking science fiction ideas and turning them into science reality. That's what we're talking about here. And once science reality happens, business reality can happen. We've seen that with a lot of different technologies through the years. I say right now it's time to party like it's 1999, at least in terms of the space economy, because it feels like the year 1999 for the internet. And a lot of what we're talking about is not esoteric things. There's nothing more fundamental to a society than rocks. We name ages of humanity after the materials we have access to. Stone Age, Bronze Age, Iron Age, Nuclear Age, Silicon Age. We're entering the Metallic Age, when critical minerals dominate the discussion about what we can do as a technologically sophisticated society. Higher order quantum effects and things like that are all enabled by mining. It comes from dirt, it comes from rocks, and that's something Arizona understands extremely well. So we've got a spectacular panel today. On my right here is Anjani Pollitt. She worked the Deputy PI at U of A for OSIRIS-REx. We've got Chel Stakistan, who does strategic planning and business development through KinetX Aerospace, and of course, Matt Jolich, co-founder and CEO of Astroforge. I'm Zaheer Ali. I created and teach in the Space Business and Leadership and Policy program at Thunderbird. I'm also managing director at New Space Finance, where we help bring capital and innovators together. And so we're going to jump into this really quickly. And before we move forward with some of the topics, I do want to just give my panel a moment to introduce themselves really briefly and share a little bit more about their, where they're coming to this subject from. So please, Anjani.
So I'm Anjani Pollitt at the University of Arizona, the Deputy PI for NASA's OSIRIS Explorer mission, or OSIRIS-APEX, which is a follow-on mission from OSIRIS-REx, which went to asteroid Bennu and brought back a sample of asteroid Bennu, which is being studied on Earth here now. I was very much involved in OSIRIS-REx operations and sample site selection, all of that stuff. And I started my career at the University of Arizona doing operations for the HiRISE camera on the Mars Reconnaissance Orbiter. So I'm coming from the academia research operations side of things, doing supporting some of the fundamental research into asteroids that can help inform the commercial side and the interest in space mining.
Hold on, is it working? There we go. I'm Matt Golich. I'm the CEO and founder of Astroforge. I'm probably the craziest guy on this panel as well, because I thought I could take what NASA did and did it for a fraction of the cost, and hopefully that's still going to be true, but it's really hard. Obviously, the goal of Astroforge is to actually be a commercial asteroid mining company, and we want to go for it, right? We want to go for it at a high rate of speed and a high cadence, and I think we'll get into more about how that's enabled and how that's talked about, but I think the important things to note from that intro is that, did you call this the Metallica Age? I want to name it the Metallica
I like
Age.
Metallica
That
Age.
sounds way fucking cool.
Are you the master of puppets, Matt?
I mean, I might be.
Can you hear me? There we go. I'm Chel Stakistad. I'm one of the founders of KinetX. Started my career at Lockheed years and years ago. Anyway, our company at KinetX, we've worked successful missions in defense and civil and in commercial. We started on the commercial side working on Iridium right from the beginning, and then helping them with Iridium next. The company could be really kind of divided into two pieces, one of which is we do deep space navigation. We work with Anjani and her team at OSIRIS-REx and did the navigation for OSIRIS. We also did the navigation for Messenger to put something around the planet around Mercury, which was really cool because I grew up on the beach, and we lengthened the mission of Messenger by doing solar windsurfing to keep it up for an extra year and a half. So it was like learning, taking something we learned as kids and applying it to space. It was cool. We also did the nav to Pluto. We worked with the Emirates to help them get to Mars. And then on the other side, which is interesting, which we don't really talk about much, is the system engineering. We've worked on large-scale system engineering projects, SBIRS High, SBIRS Low, MUOS, and then Iridium, Iridium Next, O3B, not OHB, that's a company. I can't think of the one that just the UK government took over. Anyway, doesn't matter. OneWeb, thank you. So the interesting thing about all that is getting an opportunity to work on these large-scale systems and talk with the system leads and the chief scientists is we learned how projects all fit together and operate efficiently. And so if you can do some work up front, early, it really makes a difference for your long-term costs. And the last thing I'll say is that we have worked successful missions on the commercial side, the defense side, the government side, and it's been a real experience, and I really appreciate what Matt had to say. So Matt, just keep getting out there and trying stuff. That's what matters. We need to get out there and just try. Anyway.
So we've got a variety of perspectives represented here. We've got academia, we've got the crazy startup founder, and we've got somebody who's a veteran on kind of the services and associated side of these missions. So I want to start off kind of by asking about the transition from missions like yours, Anjani, right, and how what that mission represents in terms of science, what it represents in terms of showing the way for commercial enterprise, and perhaps where it goes from there. How do you see your work translating into Matt and Chell's work?
Yeah, so OSIRIS-REx is very much a science-driven mission. It's under the Science Mission Directorate for NASA, and it's very focused on asteroids as time capsules from the early solar system. Asteroids like Bennu are relatively unchanged from the early solar system. However, there's interest in a variety of things related to that. So the acronym for OSIRIS-REx stands for Origin, Spectral Interpretation, Resource Identification, Security, Regolith, Explorer. It's a mouthful, but you'll notice that resource identification is in there. So this was one of the interests that has been there for OSIRIS-REx. Now, I think with OSIRIS-REx, we've demonstrated a number of different technologies that can be applicable to companies who are interested in space mining. We've done sort of space truthing or ground truthing of observations from Earth, spectroscopic observations of asteroids, and then we went to an asteroid and then found out, okay, yes, we were approximately correct with what we studied from the ground or from space-based observatories here on Earth. We demonstrated navigating around this small body, and I'll put in the plug for KinetX. There was a lot of skepticism about the claims about what we could do in terms of the precision navigation and operation around the asteroid. So there was skepticism. We proved them all wrong, and we've done the closest orbit of a small body and the smallest body ever orbited. We've produced the highest spatial resolution global map of a planetary body from this mission. So there's a lot of amazing things that we've been able to demonstrate. We demonstrated autonomous navigation to the surface and actual interaction with the surface, which has generated a lot of interest, and we've been surprised along the way. And I think that's one of the really important things about why we need to continue basic research like this, is every time we've gone to a small body, we learn new surprising things. So for instance, asteroid Bennu was supposed to have nice sandy beaches on it based on the pre-encounter observations. It was boulder covered. It was really, really difficult to find a site to sample. And then when we actually sampled, we found out that the surface was pretty much cohesionless, and the spacecraft was actually sinking into the asteroid during that sampling. So there's all sorts of interesting lessons here that for companies that are interested in space mining, this is directly applicable to. But again, it's just one asteroid. This is a carbon-rich asteroid. You know, the main resource from an asteroid like Bennu would be water, and other, you know, it's not necessarily what you're interested in. You'll, I guess, can talk to that. But again, every time we go to a new planetary body, we learn so much.
Now that's fascinating, particularly in the fact that despite all our technology, those predictions are often wrong, right? I mean, we had the same thing with ME69 and even New Horizons, right? And that's why the calibration data and things were so critical for what we did there.
And that's why we explore.
That's why we explore. But I'd love to kind of hear Matt and Chell comment on this, because Matt, you know, I'd love to hear, you know, from your perspective as a founder, what are you watching these and saying, okay, that's something we're taking away, that's something we're taking away, et cetera. And for Chell, you're playing on both sides. You're working with commercial endeavors and you're working with governments. So what's your interplay between that?
I guess for me, it comes back to, let's look at rockets for a second. I mean, SpaceX is one of the most valuable public companies, or I guess private companies in the world right now. Elon didn't invent a rocket, and I think that's actually a really, really important part, right? There was a whole bunch of scientists, you know, Goddard, Wernher von Braun in the early days that invented that. They spent a whole bunch of resources, a whole bunch of time, wasted a whole bunch of money, but they ended up with this thing that they could change the world with. And for us, that inflection point is the OSIRIS-REx mission, is the Hayabusa missions. I get asked all the time by investors, like, well, can you mine an asteroid, or is this do you have to violate the rules of physics? And it's really easy to be like, oh, actually, we've already mined an asteroid before. Yeah, it was a lot less dirt, it was a lot less data, and it was for science, it wasn't for money and blah, blah, blah. But like the reality is they are able to show the way that this is possible. So I only come off as partially crazy, not fully crazy when I go pitch the company. But it's a really important piece to not forget about. It is the proof point that what we are going after is possible. My job is to show I can do it a lot cheaper. And that's just an economic piece. And as long as we don't have a physics problem, we can really start to build a company, build a foundation, and build an entity that people are willing to put money behind, so that we have the luxury of taking shots at it and going to space for a lot cheaper, right? But like without these programs, we don't exist. And I mean, that's been pretty clear for every business ever created throughout human history.
Thank you. Chell, please. Don't ever turn it off. Just leave it on.
Yeah, that would have been a smart move. Luckily, my voice.
Here, you can take mine.
Here.
Take mine.
All right. Well, I can't get that done either. So, you know, if we can navigate to a planet around the 3 billion kilometers, I can't turn the damn thing on.
Hello.
There we go. Thanks. All right. I love what Matt and Johnny were saying. One of the things that's really interesting to me is that getting to the asteroid, we did not know what it was going to be like. When you're orbiting something that small, the gravity and the solar wind are equal. It is extremely difficult to orbit something like that, let alone try to get yourself down to the surface. And the U of A people did an amazing job, because I would have never thought about the fact that you had to have a little flag that said, once you're in, if you go in for about a second, you better start kick the motors to get out, or you're going to get stuck. That was smart, and it turned out to be really useful. I think those are kinds of things that Matt and his team can gather, depending on what kind of.
I got to get there first.
What's that? Yeah.
I got to get there first.
Yeah, well, we'll help you if you want. Anyway, but it is doable. You can go. Some of the people in our team actually worked the NEAR program, where they landed a spacecraft on Eros, and it wasn't supposed to be able to land, but they did it. And so we kind of knew that we could do the thing with Bennu, but it was very difficult, not a trivial thing, not hard to get there. It's hard to get around it and stay there and figure out where you're going to go and then get down to it. If we hadn't have done that program, we wouldn't have known about that. And we've probably been approached for at least 15 to 20 years about people saying, hey, could we go to an asteroid and maybe find one of these protoplanets that broke apart and all the heavy metals sunk to the bottom, and we might be able to get a whole bunch of platinum. That was some guy named Jim Summer years ago. And it's possible. It's possible to get there. How you mine is interesting, because we did a proposal for NASA years ago where they were trying to figure out if you go to the moon, how are you going to build something for someone to stay in, and it's safe, and you don't have to bring a ton of stuff up there. So we thought the idea was to go to a crater and dig into the side of the crater wall and then gunite there essentially the inside and then seal the front and then have it generate some air or what, I can't remember all the details of that. But what was interesting was we didn't have any clue how to dig into the side of out of the side of a crater. So we called the guys that dug the tunnel, and they said, we've never had anybody ask us about digging on the moon. This is really interesting. And it turned out their CEO was on a yacht in the Atlantic. They got a hold of him, and he said, okay, I'm coming in. I want to talk to these guys. So the interest is there. People want to be a part of something interesting, something creative like that. And the stuff Matt's doing and U of A and Johnny, it's exciting. People like that, and they want to be a part of it. I had a conversation once with the lady who was in charge of education for NASA, educational outreach, and she was looking at recruiting the best and the brightest to come, which I applaud. But I said to her, I said, I think maybe what we should do is reach out to everyone in the schools. Doesn't matter whether they're going to be a space scientist or not, and make them feel a part of what the United States did. I remember my dad was a school teacher at a community college when we landed on the moon, and he felt like he was part of it. He paid his taxes for this, and we were a part of it. We all felt like we were a part of it. We don't kind of feel that way anymore, and we should. And I think that kind of outreach would really help. And I think projects that are exciting, like Matt's proposing to get out there and do stuff, that's great. Anyway, so this is exciting times.
It is. And especially when you weave in the political economic implications of what it means to have access to critical minerals and what mineral sovereignty means, right? This is not just a business discussion. It is an environmental discussion. Since I'm in Arizona, I have to assume some people in this room have stood on the edge of a mine. Mines are disgusting places and disgusting things in general. If we can move them off-world, our planet is going to be better for it. But there's a lot of naysayers. There's a lot of people who say it can't be done. So I kind of just want to ask Matt, what is the hardest thing in your mind about this enterprise? Is it the investment? Is it dealing with the naysayers? Is it technical?
It's not dealing with the naysayers. Naysayers are great, and if you don't have haters, you're not trying hard enough. Let's just be honest about it, right? They don't build statues of pessimists. That's the reality, right? If you want to try to change the world, you're gonna have people that think it's stupid and you're an idiot and all these kind of things, and that's great. I don't worry about it at all. I was just talking about this outside with Justin. I don't really care about the downside. I only care about the upside. And I think the upside of asteroid mining is massive. Mining is one of the most destructive processes on Earth. But you need it. You want an iPhone? Great. Your option is either be a caveman or have these horrible mines that pollute a lot. The rock crushing process alone is one of the most CO2 emissions on this planet. That's all great. The alternative is nothing else. This is the only way to provide an alternative to that humans have ever thought of. And I didn't come up with the idea. Plenty of people have thought of this idea beforehand. There's a lot of risk to it. We have to build a very cheap spacecraft, somehow get it to fly to an asteroid, somehow land on the asteroid, somehow mine the asteroid, and somehow bring it back to Earth. And I can sit here and say all the physics are figured out, and that's all great. The physics are figured out for $1.2 billion and a whole bunch, hundreds of thousands of people working on it. How do you do it with a team of 35 people, right? How do you do it when you want to try to launch a satellite for $4 million? Those are really, really hard problems to get past, but the alternative is not to try. That's not a reasonable alternative to me. So I just sit up here and fail over and over and over again than actually never give it a shot. And I guess that's all there is to it.
I'd like to toss the next thought to Chell. You've seen a lot of this discussion evolve. Right, you've worked on a history of missions, seen progression. A lot of that's been slow. Let's be real, right? It's been slow. I was 10 years at NASA. I know exactly what was wrong in those buildings. I won't say it on this stage, but
say it.
Believe me. Have you ever heard of the RIP phrase, retired in place? I'll stop there. There's a lot of people, right? And that's what commerce can provide. But I'd love, your opinion, Chell, on how you see this moving. How can we accelerate? Obviously, getting it into the commercial sector is part of it, but what else can be done in the ecosystem?
There are a couple of things. One thing that I'll bet Matt agrees with, what makes it the hardest is to go get the funding for something, going to talk to commercial or to investors.
By the way, if I didn't say funding was the number one thing, if anybody that's running a deep tech company doesn't say funding is the number one thing, they're just lying to you.
They're just lying.
Like, it is absolutely the hardest thing. I have to convince people to give me a shitload of money for a crazy idea.
And it's true, and it's not actually crazy. You have to convince them why it's in their interest to do it, and the investors have a whole range of why they want to do it. Some people want a short-term return. Some want some kind of long-term investment where you can maybe capture a market. Another is just, I want my family to be a part of something cool. All those things, and they don't tell you that up front. You have to kind of figure it out by going. I worked the program, started a program, North Star, that ended up getting funding from a billionaire guy in Canada. And it was just $3 million to get started. It took me forever to get that far. And then after that, we were able to get another $40 million from the Canadian government, the Quebec government, the Space Alliance, which is Telespazio and Teleselenia. And then Rogers, of all people. I mean, now Rogers is a phone company, but they were interested in space. And, you know, it sounds crazy, but they wanted to be a part of that. The family did. And so getting out there you have to get out there and get people excited about why this is good. Not just because it'll make them a lot of money, but you have to tell that story or they don't want to throw away their money, but why it makes a difference. And in the history of humanity, we've always, look how much we've learned by exploring through the oceans, through everywhere we've gone. We learned something new that we didn't expect to learn. And you know, what Matt and Johnny and their team will learn by going to the places they go, it's huge. We learned things we never, I think when they did the moon stuff, the Apollo program or the early NASA program, I remember reading somewhere that 1,010 different things were created that we use almost every day that came from the space program. And the government is absolutely horrendously bad at explaining why. Look at all the stuff you got. It created an economy that grew dramatically, but they're terrible at it. Maybe they're not, it's not even legal to advertise what they do. That might be part of the problem. But getting out there and saying things, and you know, guys like Matt getting out there and saying, here's a program. This is what I want to do, and here's what we're doing. That gets people excited and people behind it. And if you're going to change things, technology with computers and what they've done. When I started my career, we were using punch cards. So you could probably date how old I am at that point. But technology, you can do so much more than we could do before. And it makes a massive difference. And now AI, what could be done if we're responsible with it, obviously, it's amazing.
Terminator.
Yeah.
But let's not, I think also, look, in the science community, we all like to forget what business is actually founded on. And like, go read Charlie Munger's Almanac, and it will lay out for you how to build a business. And those rules actually don't change. It doesn't matter if I'm trying to mine asteroids or I'm trying to run Target. Like, incentive alignment is key. And you have to draw incentive alignment for your investors, for your employees, for everybody involved. So what you're saying is correct, but I also got to show that if you're going to put in a high-risk amount of dollar into the company, like there's a reasonable path to an outsized return. And I think we can all see the outside return of space mining is complete and utter dominance of all resources on the planet. And like, that's pretty cool. That's a pretty good return.
It completely shifts the political economic landscape as well, and removes, as you were talking about, you know, incentives, right? The old phrase, you know, show me the incentives and I'll show you the outcomes. That could play out with a lot of political economics on this planet, and put certain actors on a back foot should this capability be available.
There's one more thing that I think is really interesting, because we've worked a lot with U of A and ASU, and we have a number of students that have come to work for us. And the quality of the students coming out there and then getting a chance to work on real programs has made a massive difference for us. Because what we've learned as we got older is that as you get older, you get kind of stuck in your ways, and the young people come along and they're creative, they have all these great ideas. And what we found was it's the combination that works the best. where you have the older guys that have the experience and all the failures they've been through, and the young people that are out there just with these incredibly creative ideas, some of which can't work, but that combination works fantastically. So you don't want old or all young. It doesn't work as efficiently as when you have that mix. And having the relationship with the university has been a big deal for us. It's made a big difference.
Yeah, I was going to ask you to comment on that.
Yeah, I'll jump in on that topic. Well, first of all, I'll just say University of Arizona leads OSIRIS-REx and leads OSIRIS-APEX, but we work with ASU. We have an instrument built by ASU on the spacecraft. We have a team that develops the planning software we use for planning observations, also at ASU. And we have science team members who are at NAU. Plus, of course, we have KinetX, which does the navigation in concert with Goddard Space Flight Center. So I just want to emphasize that we are bringing Arizona from all over the state onto these missions. But now to the point about education, I think that's another great thing about having these missions at universities is that we can bring in students to work on these missions and they get wonderful hands-on training. It is a really exciting thing for students to be able to work on these things, and then they can either we've had students who get hired on to our team at the University of Arizona or who go on to work for KinetX or for other companies. And I think that's a wonderful, fantastic thing. And
Matt, I think
I don't
she
know,
might
do you
have some
any-
people to get you
Yeah.
past 35.
Perfect. Also, I'm from California, so just a question, and Johnny, which one's better, ASU or U of A?
That's my answer.
Thunder, obviously.
Well, I'm just going to say that the University of Arizona was the first public university to lead a NASA mission. That was the Mars Phoenix mission, not named for Phoenix the city, but for Phoenix the bird. And yeah, is also leading OSIRIS-REx. Of course, ASU is wonderful too, though.
Yeah. So, we're coming up on 10 minutes here. So I want to just pull it back. We've been talking a little bit about workforce. One thing that may not be obvious is that Arizona is at least top 4 in producing space-ready workforce. You talk about Colorado has a lot of it, Florida has a lot of it, Texas kind of, they mostly import their talent. California has a lot of it, and of course Arizona has a lot of it. But one of the questions does become, like for me as a physicist, coming up, it was either you go academic, you go national lab, you go NASA. Now that's opening up a lot. So, this is maybe more of a question just to the panel. How do you see, what would you tell an undergraduate? Is it worth going to go get a PhD, or should they go work with Matt? Or should they go get a master's, go a little farther, and then jump off? Or how would you say, how do we think about this now? Because we're at a point where we can take a moment and really reimagine what are the right exit points, right? You also need welders, you need pipe fitters, you need mechs and techs, as we used to call them at NASA. So you need trade. So how do we think about that for this emergent economy? Because it feels like if we aren't a little thoughtful, at least it'll be completely goofy.
I could jump in real quick on, as far as I'm concerned, I got my bachelor's and master's degree in math, and all I ever wanted to do was teach math because I love it. I'm such a nerd. I read math books all the time. My family thinks I'm crazy, but what's interesting to me is if I look back at it and I look at everybody I know when I've done the work, I think almost everybody to a person would suggest at most getting a master's and getting out and working for a while and learning what's out there, the details of actually making something work, and then go back and get a PhD in an area that might be focused on the things you're most interested in your work. And a lot of companies are willing to pay for that to help you with that part. So I think going all the way to PhD is not the right way. That may not be very popular. I don't know what the universities, but I think going and working for 3 to 5 years and then coming back and getting a PhD, I think that could be valuable.
I think it really depends on what you want to do. I mean, a lot of the navigators on our team do have PhDs because you're doing this highly challenging, technically challenging thing. But I mean, I I'll just give my example. I'm actually staff at the University of Arizona. I'm not a professor, and I actually have a master's in geological engineering, which I never actually used because I went and started working on NASA planetary exploration missions. But yeah, I mean, I think for a lot of cases, master's is pretty good for working in this field. But again, it just really depends on the details of what you want to do. You don't necessarily need a master's either.
I think to all your surprise in here, probably, I actually do have an education. So I have a master's degree. And I will say this, my advice is bad. I run a company of 30 people, and I am trying to convince people that are extremely well educated, that have de-risked their whole career and their whole lives by playing it safe, getting advanced degrees, going through the ranks at NASA or larger companies, to take a chance at a small company to go change the world. And like, part of what I need is the best technical minds in the world, but I also need people that are willing to take a risk. And those two things don't go together. That's why my company is 35 and not 100,000 like Boeing. And I think that's why I say my advice is probably pretty shitty.
I don't know. Bad advice is pretty far sometimes, right? We've got a few minutes left. Before I wrap up, I'd like to kind of give each of you a moment to just say, if people here leave with one thing in their head from you, what would you like them to walk out of this room with? Whoever wants to go first, because I know that might take a second to think about.
I would say that you need basic research and exploration missions like OSIRIS-REx and other NASA planetary exploration missions as the foundation for future space mining economy and other space economies. So I think you need to not forget about that when you're talking about space at large.
I'll say just don't forget the three-letter word that I think is all really important, but we forget all the time, and that's just try. So many of us are scared of failure, are scared of branching out on our own. You know how many people I talk to all the time that come to me and they're like, I would love to start a company, but I just don't have a good idea. Okay, what does that mean? Go start a company. Like, go take a risk in life that you think is going to put you in an unsafe state. And maybe, you know, we all have this vision that like everything we do is going to ruin our life and we're going to become homeless and, you know, live on the side of the road. And the reality is like, yeah, maybe that's true, but you still got to go try. Or you'll be stuck in life, you'll be 80 years old and you'll be like, I never took a risk. So I hope if nothing else, somebody in this room just gets up tomorrow and says, fuck it, I'm going to go try and do something different and does it.
I love that, Matt. I think to me that the one message is the joy of doing something and making it work. It's really hard to get space stuff to work, but my God, is it a great feeling when you actually get something to work, especially when somebody tells you couldn't do it, like Matt was saying earlier. That people will tell you that, and Johnny said it too, people will tell you that's impossible, you can't do that. But it is one of the best feelings ever. It doesn't matter the money so much. It's the feeling that you accomplished, you were part of a team. And if I could say anything else, and that's one thing I love about the company we built and we're working in, is we work really hard, but we always take the time to laugh and tell jokes and have a good time. We are notoriously bad for practical jokes because the pressure is high, you know, for the most part. And I literally love, but the joy of making something actually work. And to be honest, the guy that leads our group for deep space, he always says details matter. And I always add it to him. I said, you get the details by trying to do something, and maybe you fail. You learn more sometimes by failing than you do from success. But there is incredible joy in not playing it safe all the time and trying something. And even if only partially works, I mean, you did it. You got something to work, and that to me matters. That when you get old and, like Matt said, you're 80 and you're sitting on a porch, I just don't want to say I didn't try something. I never thought I'd try the stuff that I've been doing. I thought I was going to be teaching math at a community college somewhere and maybe publishing some papers, but this has just been incredibly fun. And all that happened because I interviewed at Lockheed, and the guy said to me, he said, well, is there anything you don't want to do? And I said, well, I don't want to do anything that involves blowing people up. And he said to me, well, that severely limits your opportunities here at Lockheed. I thought he was kidding, and I started laughing, and he was pissed. But I got one job flying satellites at a place called the Blue Cube. It was the best thing ever. And I can't recommend enough. Just getting out there, like Matt was saying, just get out and try. Try something and be a part of something, especially when you're young. That's the time to try. Anyway.
And I'll just jump in one last thing and say I would love to see more cross collaboration between, the academic side, the mission side, and commercial entities and people like
Me too.
you.
Stop
Yes.
charging us so much.
Now that's a founder's comment, right?
Yeah.
It's all about your ramp and your runway. That's it. That's the metric he's looking at on a day-to-day
Can't
basis.
we touch those big endowments at all? I mean,
Oh,
might
God.
help.
This is a public university, man. It's not, they don't give out gentlemen's C's at public universities. Matt inspired me to poke a little bit. Well, we've only got a minute left, so I'm just going to wrap up. I hope you guys have enjoyed this discussion. I hope you took a few takeaways. Fundamental science, demonstration missions, lead the way. Commercial science picks it up and then delivers a product. We've talked about everything from the deep tech of it to the people side of it and what it takes. But what I hope you leave here, my little personal takeaway for you all would be stop waiting for your spaceship to come in, right? Let's go. This is going to happen. This could literally save the world. I don't think I'm kidding. Whether it's politically, economically, or environmentally. If it prevents a world war over cobalt and platinum, that's a good thing. If it means that we stop mining in the Congo, if you've seen those pictures, they're disgusting. That's what's in my Tesla, right? It's not all clean. But this offers us an opportunity. And there are people out here doing the fundamental side, doing the middle side, and then the pointy end of the spear, going to make it work. So I hope that you all leave excited about space mining and realize that it's about when, not if. Thank you.